All right, so the next set of identities I want to introduce to you guys is what we call double angle identities. Reason why it's called a double angle identity is because if you look at each of the arguments, each of them are all doubled. Now, with sine, it's pretty easy. It's only one form, but with cosine, there's actually three different forms you could use here. And with tan, there's actually one form there too. So you may have to play around with the cosines, obviously, but that's what proving is all about. It's all about playing around and trying to make each side equal to each other. So the first type of question I want to go through is proving an identity using one of the double angle identities. And with proving, of course, you take a look at the both sides and you say to yourself, how can I simplify? How can I rewrite terms? Now, 1 can just stay as 1, but sine 2 theta, now that is a double angle right there. And sine 2 theta, we can rewrite it using this ratio, this identity. So we can replace sine 2 theta with 2 sine theta times cos theta and equal to, let's see what we could do with the right-hand side here. Now, the right-hand side here is a binomial squared. So what I'll do here is I'll actually FOIL this or distribute. So I'll go ahead and write it out as sine theta plus cos theta times sine theta plus cos theta again. So if we FOIL, what we end up getting here is sine squared theta plus 2 sine theta cos theta. That's the middle term. And lastly, plus cos squared theta. Okay, so this is what I have so far. The left-hand side does look like it could just stay as is. There's not much I can do with it at the moment, but I could definitely collect like terms on the right-hand side. So what I see here actually is 2 sine theta cos theta that does match one of the terms on the left-hand side. But you can see here that sine square theta and cos square theta actually combines to make an identity, and that is the Pythagorean identity. So sine squared x plus cos squared x, that's always equal to 1. So that's a Pythagorean identity. So I'm going to put those two together, add them, and I get 1 plus 2 sine theta cos theta. So as I can see here, both sides are equal to each other. So that means I am complete with my proof.